So for our lab and for this problem, what you're going to be doing is I'm basically going to give you a container of acid. So let's draw a little container. And according to this problem, our container's size is going to be 100 milliliters. And the concentration is going to be 0.75 molarity. Okay, so the acid we're looking at this time is HCl. And so this is the molarity and this is the size. Okay, it's similar to what's going to happen in your lab. I'm going to give you different acids, obviously, for your lab, but it's pretty much going to be the same scenario. And in your lab, what you're going to be doing is you're going to be basically neutralizing your acid by adding a base. Okay, so in this scenario, we're going to be adding the chemical SrOH2. This is going to be our base. And so for your lab, in the pre-lab, you're going to be figuring out how many grams do you need in order to neutralize or get rid of the acid. Okay, that's going to be the first part of your lab. You're going to be calculating how much base you need to cancel out your acid. Yes?
Are we going to be writing procedures on this too?
This one, no. Yeah, you're not going to be making a solution. You're just going to be adding the solid. A little bit easier. All right, so when you add an acid and base together, you make two different chemicals, right? If you guys remember, the first chemical that you make is water, or HOH. And the second chemical you're going to be making is your salt. Okay? So what we're going to be doing for this problem today is you're going to be figuring out first how many grams of base do you need to neutralize your acid, and you're also going to be figuring out how many grams of salt are you going to make inside of your solution when you mix acid and base. So that's pretty much what we're going to be doing for our problems today, and that's going to lead up to our lab where you'll do the actual thing. Okay. All right, so the first thing that we got to do in order to solve this problem is we need to do something we already learned how to do. We need to write the neutralization reaction for HCl and for our base. Okay. So what you're going to do on your paper is part A. We're going to be combining our acid, so we're going to write HCl plus our base, which is SrOH2. Okay, so we are going to be combining our acid and our base. Okay, so we said that when an acid and a base react together, we're always going to start by making water. So we're going to make water, HOH. And then the second type of chemical that we make is our salt. Now the salt is going to come from the leftovers of the acid and base. So if you guys look, HOH is H and OH, right? So the H and the OH is going to be used to make water. So that means that our salt is going to be made out of the leftovers. So we're going to take our SR. It's going to be made out of SR, and it's going to be made out of Cl. Okay. We're going to want to put the metal first, the positive cation first. Okay, so first thing you want to identify is what the salt is made out of. Again, it's always the leftovers for your acid and base. And then the real skill of neutralization is figuring out how many of each you need, how many SRs and how many CLs. So we're going to do that by looking at the electrical energy, so the charge. So if you guys remember, what's the charge on hydrogen? Plus 1. Hydrogen is always plus 1. And what's the charge on OH? Minus 1. Yeah, so minus 2 because each of them is minus 1, right? So minus 1 and minus 1. Okay, so far so good on that? All right, so we know that they need to balance each other out. So if hydrogen is positive 1, what does chlorine need to be in order to balance that out? Negative 1. Good. And then let's go to the base. If you take a look, there are two OHs, right? And each of them is negative 1. There's an SR balancing that out. So what does SR have to be to balance that out? Plus 2. Yeah, because it's balancing out minus 1 and minus 1. There's only 1. So SR is positive 2, and Cl is minus 1. And these guys are going to be combining to make our salt right here.
Two CLs.
So, exactly. We need 2 CLs to balance out the SR. So our formula for the salt will be SrCl2. Okay, so that's how we can figure out what the salt is. Okay, Yes, we do need to balance it. All right, so we still need to balance this. So let's. I'm gonna erase this part just so that we can count a little bit better. For the balancing, you guys can do it different ways. If you want to do the table and count, you can do it that way. But there's an easier way. If you take a look, there's 2 CLs here and only 1 CL here. So you need to add a 2 here to double that. And then now there's 2 H's and 2 OH's. So you need to double this to balance that out. Okay, again, you guys can use the table if that doesn't make sense to you, but you got to make sure you balance this reaction. Okay, we did balance it. Now, before we move on, we're going to label the stuff that's inside of this equation, okay? So remember, the chemical that gives up H is always going to be your acid. Okay, and make sure you label it because it'll be helpful as you do your stoichiometry. The chemical that has OH is always going to be our base. Okay, acid and base are always on the left side of the arrow. Okay, HOH is always going to be your water. And the other chemical that's made is always going to be your salt. Okay, now it's important to be able to identify what's the acid, what's the base, and what's the salt. Because as we do our problems, you guys might see, I'm not going to tell you what chemical you're looking for anymore. I'm going to be telling you, hey, find the base or find the salt. And so part of the skill is being able to identify what chemical is what. Okay. Again, acid is the one that has the hydrogen on the left side of the arrow. Base is the one that has OH. Water is always HOH. And the salt is whatever's left over on the right side. Okay. All right, so for part B, we're doing the stoichiometry. Now, what we're going to do first, step 1 for this problem, is you're going to use the molarity equation. Okay, so you guys remember this from last unit, right? Molarity equals moles over liters.
Never forget it.
Yes, never forget it. And then after that, what you're going to do is, I'm going to give you guys a couple minutes. Let's take about 2-3 minutes. Take your numbers from part B, and I want you guys to plug it into this equation to find moles of your acid. Okay, so this should be review. So find moles of your acid using the molarity equation. Take about 2-3 minutes to do that. We'll go over it, and then we'll finish up the Stoich problem. Alrighty, guys. So let's plug in our numbers. So we have a 0.75 molarity. So we plug that in for capital M. We are looking for moles, so we leave that alone. And then we need to take our 100 milliliters and then divide it by 1,000 to get liters. And that's going to give you 0.1 liters, which we plug in right here. Okay, we can find moles by multiplying the two numbers together. You get 0.075. But let's label our number. Okay, this is going to be moles of, and if you take a look at all our numbers, it's applied to HCl. So it's going to be moles of HCl. Okay, and it's important to label this number because we're going to be switching this now from HCl into the other chemical we're looking for. All right, so in this problem, it's asking us for grams of base. So we're going to take this number right here from part 1, or step 1, and then we're going to use this as our starting number for stoichiometry. So 0.075 moles of HCl, and we're going to set up 2 fractions. Okay, so the stoich is very similar to the stoich from last unit. It's pretty much the same. So the bottom of the first fraction is going to be moles of whatever you're starting with, so HCl. We are looking for base this time. So the top is going to be moles of base. The second fraction is going to be moles of base. And then on top, grams of base. Okay, so instead of looking at starting and ending this time, we're just looking at acid and base. Okay, and that's why it's important to be able to identify what your acid is and what your base is, because you need to know what you're looking for. All right, so for the first fraction, it's the same thing as last unit. The numbers are going to come from the balanced equation. And then the second fraction, the numbers are going to come from the molar mass or the periodic table. All right, so for the first fraction, the top is the base, right? We got to look for the number of the base in the balanced equation. If you take a look at the base, SrOH2, there's no number, which means it's 1. So we're going to put 1 on the top. All right, the bottom is going to be HCl, which is 2. So we put a 2 right there. If you guys remember, molar mass is always 1 mole. And we got to add up the formula for the base. So the base is SrOH2. So let's pull out the calculator and find the molar mass. Yeah. So SR is going to be 87.62. Okay, if you take a look at oxygen, oxygen is 16, and there's 2 of them. So plus 16 twice, 32. And then hydrogen is 1, so we're going to add 2. And so you should get a molar mass of 121.62. Because it's multiplied by 2. Yeah, I mean, if you do 2.02, that's totally fine. It's going to be close enough, though. Okay. So if you want to be super precise, I guess 121.64 should work. But it's not going to make a big difference.
So, like, if I just put 1 in it, and I just submit it like that, then
you're fine, yeah. Alright, so let's do our math now. We're going to go left to right, 0.075, and then you're going to divide by the 2 on the bottom. You're going to multiply by 121.64, and so you're going to get a final answer of 4.56 grams. And our base is SrOH2, so we're going to write SrOH2.
my periodic table for SR is
So for part C, what we have to do is we need to figure out how much salt is made. Our salt formula is SrCl2. And so what we're going to do is we're going to do stoichiometry again, but this time we're looking for something else. Now, before we move on to that, I want you guys to maybe circle or highlight or star this number right here, the answer to step 1 of part B. Okay, because this is the starting number that we can use for part C. We can just take this number and do stoichiometry with this number, but instead of ending with base, we are going to be ending with salt. Okay? And I'll show you guys how to do that, but we're going to look at this number. Yeah.
Does the balance equation molar mass, why'd you write that? Does it mean anything?
That's just where we get the numbers from. We get the 1 and the 2 from the balance equation, and then this fraction, the numbers come from the periodic table with molar mass. Alright, let's do part C now. So part C, we are going to take 0.075 moles of HCl, and this time we're going to set up 2 fractions again.
Oh my god, it's double quick. Oh no.
Alright, so the bottom of the first fraction, same thing. Going to be moles of HCl. But this time, we're not looking for base, we are looking for salt. Okay, so on the top, we're going to do moles of our salt. And then the second fraction is going to be grams of salt divided by moles of salt. Okay. So, if you guys look or remember, this was your formula, the chemical equation. So let's see if you guys are able to plug in the correct numbers into those 2 fractions. Okay, we're using the same balanced equation. The only difference is this time, instead of looking for the base, we are looking for the salt. Alrighty, guys. So for your final answer, you should get 5.94. Again, the first fraction, you're going to get the numbers from the balanced equation. So the salt is SrCl2, no number, so that's 1. HCl has a 2 in the front, so 1 over 2. And then if you add up your salt, SR is 87.62, CL is 35.45, but there's 2 of them. So if you add those, you should get 158.52. And then you just go left to right, divide the 2, multiply by 158, and make sure you guys label your answer SrCl2. Okay? So the point of this is to show if you mix that acid and base together, this is how much salt that you're going to make.